Hello, this is Mr. Bowen here with another mathematical video. Now we're going to be talking about angles, how to classify them, and some interesting things about them. Let's get started. First, let's talk about this idea of vertical angles. Alright, and let's just imagine, we don't even have to imagine, we can see that we have two lines intersecting at some point P. Now, let's label these angles. We have four of them, right? We have, let's see, angle A, angle B, angle C, and angle D. Vertical angles are any angles that might be opposite each other. Therefore, angle A is vertical to angle C. We can write that over here. Angle A is vertical. Or actually, angle A and C are vertical angles. Likewise, angles B and D, these are also opposite each other. These are also vertical angles. Angles B and D are also vertical. Okay. Interesting thing about vertical angles, they're always congruent, or they always have the same measurements. So here we could say that angle A is congruent to angle C, and angle B is congruent to angle D. All right, and we can symbolize that on our chart here by putting a line here and a line here, symbolizing that these two are the same. And to differentiate these two, because these two are the same but they're different than angles A and C, we can put two lines there like that. There is an interesting notion about why this is true. Why is it that angle A and angle C are actually the same? Well, let's show it algebraically. Let's see if we can figure out why this might be the case. Our objective is to show that angles A and angle C are the same. So, objective, put it down here, objective. Angle A is congruent to angle C. All right. Now, you might think it's obvious, right? You might say that angle A and angle C must be the same thing. Maybe it's just something you've heard all your life, that vertical angles are congruent. We want to show this mathematically. And you might start by making some observations about some things you do definitely know. And the first observation we're going to make has to do with some adjacent angles. And there's another vocab word for you. Let's bring that over here, adjacent angles. And we're also going to talk about supplementary angles as well. All right. So let's point out some adjacent angles here. Angle A and angle B are adjacent. What does that mean? It just means that they're next to each other. All right. And an interesting thing, they are also supplementary. In that, if we look at the whole angle on this entire line, this entire thing, this angle from here all the way to here, that's half a circle. That means that this whole thing is 180 degrees. And that's all that supplementary means. Supplementary just means that the sum of the angles, so angle A plus angle B, is equal to 180 degrees. Are there any other supplementary angles here? In fact, there are. Let's list all of the supplementary angles over here. All right. So we have angle A plus angle B equal to 180. Angle B plus angle C is equal to 180. That's this angle here, BC. That's half a circle. It's this entire line's worth of angles. Angle C plus angle D are also supplementary. They are equal to 180. CD. And lastly, angle D plus angle A are equal to 180. All right. That's a lot of information, right? Well, let's see if we can do anything with it. Let me give myself a little more room here. We know what our objective is. Our objective is to show that vertical angles are congruent. A is congruent to C, and D is congruent to B. Let's do some algebra. First, angle A plus angle B equals 180. Let me rewrite that here. Now, for a lot of what you've been doing with your equations and solving them, you've probably been solving for numbers. You can also solve for variables. And what I mean by that is you can actually subtract angle B from both sides of this equation. All right, let's subtract angle B from both sides of this equation right here. What is angle B minus angle B? Well, that's just 0, right? Anything subtracting itself is going to be 0, which leaves us on this side with just angle A, which should be equal to what? Well, 180 minus angle B. We don't know what angle B is, so we can't actually subtract it from 180 degrees right now. All right, we're looking at this unknown angle B here, and we're just taking 180 and we're subtracting that angle. All right, I'm going to use something called substitution. Substitution just means that if we take a look at all of our data up here, you see this point here where we have angle D plus angle A is equal to 180? Let's take a closer look at that and compare it with this part here where it says angle A is equal to 180 minus angle B. So, angle D plus angle A equals 180. That's just me copying this down. What if we know what angle A is? Now you may say, what do you mean we know what angle A is? Well, we do. We actually know that angle A is equal to 180 minus angle B. That means that we can replace this angle A here with exactly what angle A is equal to. It's equal to 180 minus angle B. All right, let me rewrite that down, right? Just rewrite it. Angle D plus 180 minus angle B is equal to 180. Let's use a little more algebra. Let's subtract 180 from both sides of this equation. We can do that, right? Of course we can. 180 minus 180 is just 0. That goes away. And 180 minus 180 is just 0. That goes away. What do we have now? Angle D minus angle B equals 0. Can you see the last step? Let's bring it over here. Angle D minus angle B equals 0. By the same logic that we used earlier, we can add angle B to both sides of this equation. Okay? Minus angle B plus angle B, well, that's the opposite of this, so this is just 0, leaving us with just angle D on this side, and giving us on the other side just angle B. And this may not appear to say much, angle D is equal to angle B, but it actually says a whole lot. Angle D is equal to angle B? Well, guess what? Angle D is equal to angle B is one of the things we wanted to prove, right? This angle here is congruent to this angle here. These are vertical angles, and they are congruent. And that holds true no matter what the actual measures of these angles are. No matter what number you put in for D, it has to be the same for B. By the same logic, we can show that angle A is equal to angle C. I'll leave that to you to show. You can send me a message with that answer if you like. Use this information here and the same method here to show that. So now we've shown that vertical angles are always congruent. We know that. Vertical angles are congruent. And next what I would like to do is just talk about some vertical angles and figure out what they are. Let's call this angle 1, and this angle 2, this angle 3, and this angle 4. By just knowing one of these angles, you automatically know what all 4 of them are. So let's say that this angle here, this angle 1, let's set that equal to about angle 1 is equal to 110 degrees. All right? Now, by just knowing that angle 1 is 110 degrees, we can figure out what all the rest of these angles are. Can you see how to do that? Well, let's walk through it. The first thing we know is that angle 1 is congruent to angle 3. That means that angle 3 must also be equal to 110 degrees. What do we know now? Well, the total measure of all of these angles is equal to 360. So 360 degrees minus angle 1, which is 110, minus angle 3, which is 110 again, will bring us a little bit closer to our answer, right? That'll leave us just with angles 2 and 4. So let's see. This is 360 minus 110, which is 250. Subtract 110 again, which is then 140. All right. So angle 2 and angle 4, angle 2 plus angle 4 must be equal to 140. Well, hold on a second. Angle 2 and angle 4 are actually also vertical angles. That means they're the same thing. So that means that angle 2 plus angle 2 is equal to 140. Or another way to write this is just that 2 times angle 2 is equal to 140 degrees. Okay? I'm going to put some parentheses around this so we know we're talking about angle 2, not the number 2 right here. All right. Let's use our algebra to solve this. Let's divide both sides of this equation by 2. All right, that will leave us just with angle 2 here. And on this side, 140 divided by 2 is 70. Now we know that angle 2 is equal to 70 degrees. And likewise, angle 4 must be equal to 70 degrees. And there you have it. Just by knowing that this angle here was 110 degrees, we now know that what all of the angles are. There's a quick check just to make sure, if you ever want to make sure you did it right. And here you go. By taking all of these angles and adding them up, 110 plus 110 plus 70 plus 70. By adding all of these up, we should come up with 360. And we do. And that means that the circle is complete. All 360 degrees of the circle have been used, so we must have our correct answers.